Hello, everyone. My name is Stephen Summerow, and I will be talking to you today about urban sprawl and its impact on air quality. So, before we get started, I'm just going to give you a basic outline of what I'll be doing today, or how I'll be going about this process. So, first of all, I'm going to give you some background on the topic. So, what is urban sprawl? Because I feel like no one really knows what that is as it's an ecology term. And then also I'm going to talk about why is urban sprawl and important to study. So what aspects of different life does it affect and how does it affect everyone on their day-to-day basis kind of deal. Also I'll be going over like what it is, how it affects our day to day, and then how it impacts air quality among the US and how, so yeah. And then I'll be going over some key words that will help with explaining the data and results that are common ecology terms that discuss urban sprawl. And then I will be going over the focus of the study, what the study talks about, how urban sprawl has affected air quality in many aspects. And then the methods, how the scientists did the process of everything, and how they, and then which leads into the results of how the scientists came up with the results, and then summary of the tables. And then lastly, we will end with a take home message. Just a pretty much just a summary of what the paper was talking about and how yeah, and then the resources. So to talk about this, what is so the focus of the study pretty much is, are metropolitan regions characterized by high levels of sprawl associated with greater quantity of ozone precursor emissions from vehicles and industry than more compact regions? So pretty much the first point of this, the first focus of the study is talking about how urban sprawl, how high levels of expansion deal with a greater like quantity of ozone, which is a colorless gas that is formed in the presence of sunlight through the chemical interaction of nitrogen oxides and VOCs, which are volatile organic compounds. So as people are driving, the emissions from cars leads to a greater quantity of ozone. So this kind of explains, and we'll get talking to it later, about how and why you have to get your emissions tested in certain states, which I bet a lot of people don't realize like why, but it is an important process that can save some type of air quality and improve the air quality. Secondly, the second focus of the study is, do metropolitan regions characterized by high levels of sprawl experience a greater number of annual ozone exceedances than more compact regions? So then again, it talks about how if there are high levels of sprawl, and how are these greater numbers of ozone exceedances, how do they compare to more compact regions such as cities where you have to walk to work, you're not necessarily driving, like you're not coming from, so for example, you're not coming from the suburbs like Marietta and Brookhaven to go into downtown Atlanta to work and do other activities and such. So you might ask, what is urban sprawl and why it is important to study? Why am I talking about it? So urban sprawl is the outward expansion of cities and towns. So pretty much you can see in this diagram that this is a diagram of the city of Atlanta. So in 1985, you can see right here in the middle, this is downtown Atlanta. So you see it's a high intensity, by the red bar, it's high intensity buildup of land. So what this means is that it is a more compact area. There are more people living in this region compared to the outskirts of Atlanta out here. So over time, you can see in 1992, the red and the yellow are starting to expand even more. and then 1999, and then 2005, it's even more. And you can kind of see where the outward expansion goes to, because at the end around here is where 285 is going around the outskirts of Atlanta. So then in 2012, you can see the outward expansion. And then, I mean, I bet you can't even imagine. It's probably way more now in 2022, with people always moving to Atlanta and always coming to the city. So next, you can see, so urban sprawl can also cause the levels of ozone to rise. So as I mentioned earlier, how ozone is from emissions of different aspects, such as car emissions or particulate matter, which is small pieces of dust and other particles from such as construction. So when there's a lot of construction going on, such as in the city and on the outskirts, it creates this fine particulate matter, which goes to the ozone, which causes worse air quality. So because people are driving from the suburbs to downtowns, like, or bigger major cities, this causes the levels of ozone to rise because of the emissions. So the more you drive, the more emissions you and your family build up. So as people are expanding outward into different cities, it causes the ozone to rise. And so along with this, it also can cause a urban heat island effect. So pretty much I would go to this in the next slide. So this is an example of an urban heat island profile. So an urban heat island index is pretty much where you see how the temperature rises when you get to a city. So when you get to the city, there's less impervious surface. So Stephen, you might ask, what is impervious surface? An impervious surface is where water cannot go through, it cannot soak into the soil. So you see, you go from the rural areas where there are a lot more trees and soil, not as much concrete and buildings, where the water is allowed to seep into the soil and cool off the earth. You can see that the temperature is lower. And then as you get towards downtown and more residential places, you can see that it slowly starts to rise. And this is because water tends to cool down the cool down the cool down the soil, or I mean the ground. And then also you see that that when you have trees, it's a lot cooler, which trees provide shade and such. So So it also urban. So when you're driving to downtown, it also can cause a lot of emissions and VOCs too, which is another reason why it causes an urban heat island profile. So as you see this, the vehicle engines and gases, when you're driving around downtown, it slowly, you see people start coming from suburban residential areas and go to downtown, and the heat rises, the temperature rises as you go towards downtown. So next, I would talk about the methods of the study. So pretty much the methods of the study, scientists looked at 45 of the largest metropolitan statistical areas. So you can see Atlanta, Los Angeles, Sacramento, San Francisco, and then you can see the MSA population is in millions. And then you can also see a number of annual ozone exceedances per region. I'm sorry. The number of annual ozone exceedances per region was compiled over a 13-year period between 1990 and 2002. So over the 13 years, they compiled all this data that we'll get into a little bit later. But pretty much, so some of the data, most of the data comes from the EPA, which is the Environmental Protectant Agency, and the EPA pretty much reports the number of days per year for which ozone exceeds the national ambient quality standard. So EPA regularly examines the air quality between different regions and such, and how long and how many days of a year the air quality is above the standard for that city. Also, a lot of the data was also presented from the National Emissions Inventory, which also compiles data over on data of emissions at the county level. And then another point to mention is metropolitan data of the annual temperature and trends was obtained from the National Oceanic and Aeronautical Administration's National Climatic Data Center for each year of the study. So over the years, these scientists collected all this data. So as a control variable, the scientists used the average ozone season to account for the effects of temperature on ozone formation rates in different climatic regions. So yeah. So in a study, it's best if you have a controls to know that your data is not having flukes or anything like that. So they also had a population size control to also, so that the amount of people in an area does not control how much emissions and such are going on. So next we're going to look at some keywords, which are going to be very important when we are looking at the data. So for the first keyword, it's centeredness, which is a spatial variation in density over an area. So pretty much, as you can see in the previous slide, for Atlanta, you can see that there's a big dot right there. So the centeredness is, so downtown Atlanta is the center of that population. So in the study, the results were compiled of a Sprawl index. So centeredness, connectivity, density, and land use mix were all formulated and all used to compare data for all of the different 45 cities. So for centeredness, it was a composite measure and derived through principal components analysis with data obtained from the 2000 census and the Claritas cooperation. So next we can go to connectivity, which is how street networks are connected by block size. So pretty much the connectivity is how street networks are connected. So if you're going from one street to the next, how is it walkable? So how can you go from one part of the city to the next without driving your car, without creating emissions? So they use the connectivity as a measure of density of the street network, which was based on the average block size and the percentage of less than approximately 500 feet on a side. So pretty much, for connectivity, as the block size increases, it's an indicator of street network density. So as blocks continue to grow and the street networks continue to connect, it creates a higher connectivity for that area. So next we can go to density. So pretty much density is how many people are in a population in a certain area. So in the centeredness of the area, how many people are living in the area? So for example, density would be how many people are living in downtown Atlanta compared to how many people are living to Brookhaven. So if it is a dense environment, that means that there is a lot of people living there to create the population in that certain area. So for density, the measures came from a 2000 census from the USDA Natural Resource Inventory, from the American Housing Survey, and the Claritas cooperation, which also the Claritas cooperation helped with the data for the centeredness. So next we can go to land use mix, which are different types of land uses and are physically and functionally integrated. So land use mix compares to, like in the first slide, or remember when I was talking about the heat island index, it went from rural to suburban to the city and then parks and such. So land uses are different types of land that are within that area. So different types of parks, the city, rural areas and such. And the land use mix was calculated by the elements of ratio to job population and the accessibility to residential uses and non-residential uses, and the levels of how much transportation can get you from one area to the next. So in summary, the land use mix was it pretty much determined how much of one how easy is it from you to get from your residential area to the city where it is a more compact and more dense area. So when we look at the results in the next slide, we'll be able to see the sprawl index. So sprawl index is a measure of how much sprawl occurs in an area. So as I mentioned earlier in the presentation, urban sprawl is the outward expansion, how much people are moving outwards toward more rural and suburban areas. So the sprawl index was calculated from how much centeredness, connectivity, and density and land use mix were occurring in these areas. So in this first table, we are able to see the centeredness, connectivity, density, and land use mix with a with the urban form and mean annual emissions of NOx and VOCs. So as I mentioned earlier, as a reminder, NOx's and VOCs are nitrogen oxides and volatile organic compounds. So in this table, you're able to see that there is a strong correlation, strong association between urban form and population density. So in this table, you can see the 0.020 is of significance. So it's of significance of the it is of significance. So saying that it is it is of a significant difference, which means that that in density, that this is showing a strong correlation between the between density and the mean annual emissions of NOx's. So in summary, that density is shown to have a strong correlation with a expansion with a great amount of of nitrogen oxides and VOCs. So next, because of table 3, so because of ozone deals with emissions precursors and meteorology. So because ozones have a strong correlation between meteorology, it is important to realize that there are other areas and other things that can affect the temperatures and other things like that. So because of this and how meteorology has a strong correlation with emission precursors, another study was done to show the regression results from urban form and mean annual ozone exceedances. So in this table, you're able to see that there is a significant difference in centeredness, connectivity, density, and sprawl index. So in table 4, you can see that it expresses the spatial and structure of large metro areas and ozone exceedances. So in this table, you can see a correlation between density and in both density and density in both of these. So in both of these studies, density was the highest amount, which shows that density has a strong correlation between urban sprawl and the air quality. So because of this, because of the first two models support the hypothesis of the scientists that urban sprawl affects areas of affects annual emissions and affects the air quality in different parts of the United States. So because of this, and they were both, because of the first table 3 and table 4 were both emission-based and non-emission-based mechanism, it was a further possibility that non-emission-based mechanisms were more powerful than influence on ozone formation. So another study was done to look at this. So in table 5, the results support the hypothesis that urban farm influences regional ozone formation through both an emissions-based and non-emissions-based mechanisms. So in this, you can also see there's a strong significant difference between connectivity, density, and the sprawl index were all shown with significant difference, supporting the hypothesis that regional ozone formation through both emissions and non-emissions was of strong correlation to a negative air quality. So table 5 pretty much confirmed all of the results that we had already previously seen in this study. So some take-home points. So pretty much because of the study, each three of the tables, each three of the studies that were done in this paper, all show that urban sprawl leads to worse air quality within the cities. So because of the emissions and a heat island effect, it was shown by these studies that the air quality has gotten worse over time because of the emissions and because of emissions and particulate matter that can increase the increase ozone. It can increase ozone, which causes worse air quality. So because of this, this show also shows that more compact areas of living will reduce urban air quality problems. So looking forward, as you're moving to cities, as you're thinking about how can we be more urban conscious, more environmentally conscious, we can think about living more in the city where you can walk to work, where you don't have to drive 30 minutes from like Marietta to downtown Atlanta, for example, to go to work or go to school. It can often decrease the amount of emissions and better the air quality for everyone that is living in these areas. So thank you so much for watching my presentation, and here are my resources.